In this video, we will look at how the Telpher was made for the Gasworks. A Telpher is an overhead crane system running on a monorail. In the Gasworks, it is used to transport coke from the retorts to the coke stockpile. On the way, the hot coke has to be quenched to avoid the possibility of it catching fire. The quenching tank is just outside the retort house. The Telpher runs right inside the building to pick up baskets into which hot coke has been raked out from the retorts. The vehicle is a crane unit running on a single rail with a winding drum to lift up the load. The whole thing is powered by electricity, which is fed from a trolley wire above and returned via the single rail. Our model is based on this photo. For our Gasworks, we wanted to have a junction with a short line off the main running line for a Telpher shed. This required a switch in the track. These are made from a short section of track that pivots to give either a curved route or a straight route. The overall model requires a number of elements: the Telpher vehicle, the support track, the pylons, and the Telpher shed. Starting with the vehicle, a model was created in CAD containing the cabin and structure, the traction motor system, the winding mechanism, and the coke basket. Even the gears were modelled in the winding mechanism. The vehicle was then broken down into components and laid out in a tray ready for 3D printing. And here is the completed Telpher vehicle. The track girder was made up from 5mm by 1mm flat brass strip, with top and bottom flanges made using 3D printing. The top flange has moulded into it the crane rail style fixings for the running rail. The running rail is threaded in once the beam has been assembled. This plan shows that our track has two parts: a straight run between the coke pile on the right and the Telpher shed on the left, and the branch with sharp curve to get into the retort house at the bottom. On the sharp curve, there is another girder above, which spans in a straight line between adjacent pylons and has supporting U-shaped brackets to connect to the curved track beam below. Here is our model of the points operating mechanism at the junction. The pulley at the right-hand end of the operating rod has a chain over it which hangs down within reach of the Telpher driver to change the junction. There are three variations in the support pylons for height and configuration. The Telpher beam is connected to the girder near the top, and the Telpher vehicle passes through the gap in the middle. The pylon is made using traditional modelling from brass angle, phosphor bronze strip and brass section, all soldered together. This gives a lightweight, robust structure. This photo is valuable because it shows the Telpher shed perched high up, straddling the track girder. You can see underneath the shed there is a walkway and platform for accessing and maintaining the Telpher vehicle. Our design is slightly simpler and is attached directly to the track girder. The Telpher vehicle only just fits into the shed as long as the basket is fully up, otherwise it fouls the platform. Here is the final assembled model with pylons, track, shed and vehicle. The site is extremely cramped, with coal stage on the left and three Telpher pylons straddling the railway track below. And finally a view from the railway viaduct showing the Telpher. In the middle of the photo, you might just be able to see the chain hanging down for changing the track switch. That concludes our presentation about the Telpher. Thank you for viewing, and we hope it was of interest to you.